All right, guys. So, again, we're reviewing all this week. Classwork for today. Homework for tomorrow. If you really know your stuff, you can maybe knock it out in class. All right, but I want to walk through some of these with you. You're welcome to work independently, but I kind of want to put something out there on a video. So normally I don't do that. I just say, hey, get together with each other, work, whatever. But I still know that we have a couple people out. So I'm going to just walk through a couple of these, make sure you're in good shape, or at least have a plan of action, because a couple of these, especially if you're not doing every homework problem, might come as a bit of a surprise to you. So I'm not going to do all of them unless we have time, which you very well may. But on number 8, anybody know what they would do for number 8? To integrate that. Is there anything special? Is it rules? Is there a U substitution you have to make? So really, there really is no substitution required here, right? And since you're adding, you can basically integrate the first part and integrate the second part and then just join them back together. So what's the integral of e to the x?
E to the x.
All right, so e to the x, technically plus the c. What's the integral of 3 to the x?
3 to the x over ln 3.
3 to the x, but over ln 3. And if you're bothered by that, why doesn't this one have to go over ln e? Well, it does, but ln e is 1, so we don't bother. And then the two c's that each of those make would combine together to form just some third c. Right? That's just strictly rules. Now, number 11, anybody got any ideas? And literally, this is from your what to do with the Dwight at the bottom, you know. Now, technically, you could do long division, but I don't do long division when I have a monomial, personally, because it's, to me, a waste of time, because all you're really doing is dividing that into each part. But if it was a binomial, because it's a bigger power on the top, definitely. But you can do it if you want. You can go x squared into that, and you'll get x plus 1 over whatever. But to me, it's easier to just do this. And that would give me the integral of what?
X.
X plus,
X.
yeah, 1 over x, which is x to the negative 1. But I don't write x to the negative 1 when it's just a single x, because of what? The power rule won't work for me, will it? So I have to actually, when it's 1 over x, I use the natural log rule. But the last one is what? 1 over x squared, and that I will definitely write as an x to the negative 2 dx. And I think I said somewhere on these, I'd encourage you to use your own paper, but I'm just using the wall here, just so you'll have room, because a lot of these I'm going to need more room. And then how do I integrate each of these parts? The integral of the x would be x squared over 2, or 1/2 x squared, either way, I'd probably write like this. And the integral of 1 over x is what? ln absolute value of x. That's a rule, right? The only time it's ln is when it's an x to the first in the denominator, or a u to the first. Any other power, you move it up like you did in that third part and treat it like a power rule. And then the last part, so the rule is x to the, you add 1 and you get negative 1 over negative 1, which ends up giving you, so you could write it like this, or you could write minus 1 over x plus c, right? Either one's fine, or you could even have a plus there and have a negative 1 in the bottom. You could have something like that. It's pretty ugly looking that way, but you could. All right, so now what about number 3? Or 12? Oh, I know why I did this. Never mind. I used to have a huge, massive worksheet with zillions of problems on it, and I handpicked them because, but anyway, it's a long story. Whatever. I didn't want to redo all my keys from that, and it used to be from some book we used, but the book now is long gone. So anyway, ignore my weird numbering. So number 12, help me out. said u substitution. It certainly is not a rule. So, and if you're thinking, well, I could FOIL that out and then put x under it, maybe as a last resort, but what would you think about a u substitution? Like, anybody have an idea what they pick for u? I'd probably go with 1 plus ln x. I have seen people go with just ln x as your u, and it actually works, but it makes your life harder. Okay, but if you do treat your u as the 1 plus ln x, then your du would be what? 0 plus 1 over x dx. So circle the u, there it is. Do you see the 1 over x dx? Yeah, 1 over x dx. So there is my du. So what does that give me? That gives me the integral of u squared du. So I have a power rule. So what do I end up with? So u cubed over 3 plus c, and then you plug the u back in. And you certainly don't need to FOIL all that out. What about 13? Yeah, so this is definitely not a rule, so it's going to require a u substitution. I usually gravitate towards the highest powered thing as a u, and that's going to work for me here. That higher power would be the t squared, but again, I'm just trying it, right? I'm not doing it. So if u is t squared, what is du? 2t dt? Do I have a 2t dt? Not yet, but I can fix that, right? With a 2 and a 1/2. And then again, I'm circling the 2t dt. Guys, if you're missing these, try what I'm doing. Don't keep resisting it. Like, people are like, that's too much time. I'd rather miss it. I mean, that doesn't make any sense. Try the circle little thing and then bring over. What do I have? I've not circled the half. I've not circled the integral. I've not circled the e. So I have e to the u, and everything else is my du. And write that step. All right, especially if you're missing them. If you're getting all of these right, then what you're doing is working. But people keep resisting my suggestions every year. I'm like, dude, they're like, I got this. I only miss them because they're careless. I'm like, no, it's not that. So what is this now? 1/2 e to the u plus c, and your u is t squared. All right, what about 14?
Can you move the 5 out this way?
If you want, it's a constant, and you're multiplying by it.
Then u is x squared plus 3.
So that's what I would do. And again, that whole, try to pick the part that has the biggest power. So if that's u, if u is x squared plus 3, what's the du?
2x dx.
2x dx.
So move the 1/2 out and put 2 on.
So I can put a 2 there, balance it with the over 2, 1/2. There's my u, the 2x dx is my du. So what am I left with when I rewrite this? 5/2
Times sine.
integral of cosine u du. Now I got a rule. So what's the integral of cosine u? Sine u. So I'm going to copy down the 5/2 sine of u plus c and take my u and plug it in. You seeing it? Now, what do you see here? By the way, this is not sine of x times that. Like, all of this is not in the sine. It's really this. Sine x times that dx.
U is 2 plus cosine x.
Why not? Let's give it a shot. And why would you think that, George?
Because when you plug the derivative of cosine, it is sine.
Okay. Why wouldn't you pick u to be sine? Because the derivative of sine is cosine.
It would be a
Actually, there's a negative, but go ahead. Do what?
It'd be hard going under the,
It'd be impossible, actually. Yeah, see, if I pick u equals sine x, then my du would be cosine x dx. And you can't go, oh, but look, it's right next to the dx. It's under the radical, joined to a product of 3 and added to a 2. You can't just grab that and pull it out, right? It's involved in another function. So if you did try this, there's no shame in it. Nobody's going to prison. It just didn't work for you, so try something else. And also, if you pick u, sometimes I see people pick u to be 3 cosine x. And you could, and that would still be absorbed with that, but then you'd end up with the square root of 2 plus u. And you would literally have to do another substitution to get it to work. So why not just join the 2 in with that? And if you saw that effortlessly, great. And then so your du would be what? 0,
3 sine x dx.
careful,
Negative.
-3 sine x dx. Because remember, even though the integral of cosine is sine, you remember the derivative of cosine is negative sine. So how do I make this work? I need a -3 multiplied there, so a -1/3 on the outside. So there is my du. So what do I end up with?
Root u.
Well, before that, I'm going to rewrite it, especially if you've been having trouble. Do it. Just trust me, it doesn't take a lot of extra seconds in your life, right? So I end up with the square root of u, right there, all of that's du, and now I go, oh, square root of u is just u to the 1/2. So that's a power rule. So what's the power rule tell me?
Plus 1.
So add 1 gives me u to the 3/2. Over 3/2 is times 2/3. Don't forget a plus c and take your u. Didn't leave a lot of room there. Take your u and plug it in there. And you know, I like you to clean stuff up, but on the AP test you wouldn't have to.
We have to on your test, like.
I know you always ask that. It's not gonna kill you, man. But especially in a multiple choice, you're gonna see this. Y'all with me? That's 15. 17. What about this? What do you mean it doesn't work?
If you.
What? Yeah, it's just an uglier u substitution than we're traditionally used to, right? But you can do it, right? And what's kind of usually the hint to those?
The radical.
The radical has a binomial in it. And remember, if the radical had a monomial in it, I'd have like bases and I could multiply the like bases and add the powers. But because there's a binomial in there, or worse, can't really do that. But by making a u substitution, I can kind of switch the roles, right? Like I can say, all right, I'm going to let that be your u. Then my du is just what? 0, -1 dx. So there's the u. The -1, I can make that work. -1, 1 over -1. But look, the problem is, even after circling everything, I still have an x left in there. So that's when I solve. X would therefore be 1 minus u. And I'm going to replace that with a 1 minus u. And then look what I end up with. I got this negative, I'm going to put it down here. I got this negative on the outside. There is my 1 minus u. Now I have square root of u, which is u to the 1/2 du. And the advantage of this, and they look similar, one has monomial times a radical with a binomial, but now I have a binomial times a radical with a monomial, technically, and now I can distribute it. I couldn't do that before. I mean, technically I could distribute the x inside there, but then I don't have a rule that helps me. So what do I end up with? The integral of u to the 1/2 minus u to the what? 3/2. Good. And all of that's in parentheses. And once I get to there, I can use my power rule. So what do I get?
Negative.
I'm going to make a mistake here on purpose. Negative what? U to the 3/2 divided by 3/2, which is times 2/3. Right? And then what? Oh, so you're saying this negative has to be distributed.
Yes.
It's really easy to forget that. And if it was like a -2, don't forget to distribute whatever that is, whether it's -1 or -2 or whatever. And then that ends up being u to the 5/2 divided by 5/2 is the same thing as multiplied by 2/5. And then u was 1 minus x. And don't forget a plus c.
That's a pretty great problem.
And you're gonna have one like that on your test, where you have an ugly u substitution. But it probably won't be as ugly as the one we talked about yesterday, where you had to split up the x cubed into the x and the x squared. I like that. I thought it was a good problem, and I'm not saying AP could ask you anything that we've talked about, but didn't really feel like something that they would traditionally ask. All right, what about 19?
Use substitution.
All right, anybody got any ideas?
2y should be plus 4 is 4.
So you want to make that your u?
Yes.
So your du is
6x squared.
6y squared dy?
Yeah.
Do I have that?
Multiply by 2 and 1 half.
Yeah, so since I can just multiply by 2, now if that number was something like 8, don't overthink it. If it's something that's bothering you, you're like, how do I turn an 8 into a 6? Just hold the, like for instance, if it wasn't obvious to you, I could multiply by 2 and a 1/2, then just pull the 3 out, right? And then multiply by a 6 divided by 6. Are you with me? It's the same difference as multiplying by a 2 and dividing by a half, and multiplying by a half, because that's what you end up with. But I think in here, most of you right now would see that 2, 1/2. So there's your 6y squared dy, all of that. There's your u. So that simplifies to 1/2 integral of sine u du. And what's the integral of sine? Negative cosine. So drag the 1/2 over, negate it, cosine u plus c. And then again, your u is 2y cubed plus 4. All right, here's the last one.
Yeah, sweet.
Yeah, this is just one of the rules that we.
Could you move the flat?
Huh?
Could you move the flat up a little?
Oh, crap, wait a minute. Yes, but I told you you didn't have to worry about natural log this. I mean, integral of ln x.
Yeah,
Yeah.
I have no idea.
Okay, technically, this is an integration by parts problem, but
Oh.
I used to have my classes memorize this, that the integral of ln x dx was x ln x plus x plus c. But you only know that through integration by parts. And integration by parts was that thing I mentioned to you yesterday. If you ever see a u, du, and a v, dv, that you can skip that. But I always had people memorize this little formula. And the way you would apply it in this case is to just swing the 5 out to the front because of a log rule, right?
Yep.
So if I swing that out to the front, then technically I can bring it all the way out. And then I could just apply my rule. X ln x plus c. Might be minus. I think it's plus.
Minus c?
No, it might be a minus x, but
It's
I,
a minus x.
is it a minus x? Okay, yeah, minus x. But I used to have y'all memorize that, and then you distribute the 5 in and get 5x
But then
ln x minus 5x plus c. Yeah, but because we're not going to do integration by parts at all, unless we stumble upon some free time, which I don't see how we are since we're already like a week behind.
yeah.
I'm just cutting that out. So you could ignore that problem. But should you ever run into those in college, rather than treat this would be a really ugly u substitution, integration by parts if you don't swing the 5 out. Like really ugly. Like it's this multiple step process. Sometimes you even have to use this table method that I have in your notes if you want to look over that. But if you just swing the 5 and know the formula, really easy. Yeah.
We also skip number 18 and middle column. X ln x squared dx.
No. U substitution works on that. Oh, because it's an ln x.
Yeah.
Yes.
Yes.
Yes. Now there's one up here that I saw that I wanted to show you, and if I don't see it,
Is it 33?
no.
Why don't you show us 33? Yeah, you just ran away from
Okay, let me just show you a random one.
Same thing.
So what if I gave you this?
I'd move this.
Swing up the two. And then make the use of swing up the two. Swing the two up. Making use of it.
Now, a lot of people try this. A lot of people go, well,
Just cancel it.
I'm gonna let u equal x squared because I'm used to grabbing the highest power. And then they go du equals 2x dx. And then they try to pull this number. All right, there's my u. There's my 2x dx. And they try that, and that just doesn't work, right? I mean, it may work for you, but it's not going to work. All right, so I've already heard it correctly from somebody.
Equals ln x squared.
What do you think I should do then?
Move it to it.
So if I swung the 2 out to the front, which really I could bring it all the way out, right?
Yeah.
Then what could I make my u?
ln x.
See, now if my u is ln x, what's the derivative of a natural log? 1 over x dx. Ah, 1 over x dx. So there's my u, there's my du, 2 integral u du. Just ends up being a power. Y'all seeing that? So you get 2 u squared over 2 plus c, so u squared plus c, and your u is ln x. And by the way, you can write a natural log like this, or you can write it like this, kind of like you do with trig functions. But why is this wrong? Because that's saying just the x is squared, right? And you're really squaring the whole log. So you would either see it written like that as a multiple choice, possibly like that as a multiple choice, and probably like that too, just to screw you over, because they're constantly trying to find ways to trip you up. But make sure you know that it's one of these two. And either one's fine with me, but if it's multiple choice, you'd be looking for that, not that. Because that's not squaring the whole log, that's just the explanation. And then here's another one, hold on.
If we saw like the ln x, the quantity squared and then ln squared x, would we like immediately eliminate those two answers because they're the same thing? Like for a different problem?
Yeah.
If we see two
Because it couldn't be both,
Yeah.
I suppose, yeah, logically. I have never seen an error on one of their tests, ever. They do a pretty good job, so I would.
Not that it's an error, just that it's meant to confuse people.
Right. But what I mean is, because I've never seen an error, that would be logical.
Oh, alright.
Yeah. Trying to think of one.
This was one. So. Simple. Integrate. And find the C value. I do not care.
Alright.
Integrate on. It has been moved.
Yeah, I guess it has to have two excuses. It's an A
Alright, how about this?
It's just, you're right.
But let's just look at it for fun.
Probably my favorite part.
It like has no C.
Yeah.
Alright, help me out.
Can you change the tangent first to make it better?
Possible. There's lots of ways you can do it. Maybe not lots, but there's a number of ways.
Do you even have the ability to change it?
Let's not change it, just see what we can do. And then we'll look at it that way.
Could you,
I mean,
We'll do both.
could you change the cosine squared?
Do what? Hold on, do what?
You could change the cosine squared
2?
to like 1 plus sine squared. Or I mean,
1 minus sine squared? You can, does it help you?
No, but it's something you could do.
But it
Could.
adds another term.
And listen, I'm not gonna suggest that even that might not be helpful, because it's possible. But right now, it's clearly not a rule. And if it's not a rule, you're trying to make it look like one with a U substitution. So if you gotta pick a U, anybody got any ideas?
3x minus 4.
Cosine 3x
Okay, if you do,
Yeah.
if you do that, and you can pick a U as 3x minus 4, just tell me, does it help you get to where you wanna go? So this is what would happen, U 3dx, so you would end up with 1/3 integral tan U cosine squared U du. To me, it didn't really get me where I wanted to go, so I don't think it's enough. Now you could, from this point, do another substitution, and by the way, don't continue to use U if you do that, use W or some other variable. But since it didn't get me really where I wanted to go, I'm gonna try something better than that.
If you change the cosine over cosine and then have U cosine of 2x.
Okay, I'm just gonna go with it because he keeps suggesting. If you change tangent to sine of blah over cosine of blah, and then, listen, there's nothing wrong with this. This is a good way to do it. Sine of that over a cosine of 3x minus 4. That cosine of 3x minus 4 is going to be along with this cosine squared of 3x minus 4, giving you a cosine cubed of 3x minus 4. So listen, if you think to do this, great. It's not a problem. It's a great idea. As long as you're getting there. In fact, your answer might even look different than mine, but it would mean the same thing. And I'll talk about that in a second. So at this point, what would you do?
U as cosine of 3x minus 4.
Do you see that? I'm going to pick U to be this. Now, I'm not going to pick U to be the cubed, because look what happens if I pick U to be the cubed. I get du. You remember how to do these? You do the power first, 3 cosine squared, and then you do the cosine part, negative sine, and then you do that part, times 3. And that, there's just not, that doesn't exist, right? I've got all this extra junk in there. The sine part's there, dx, but there's just too much. So that was a bad choice if you decided to do that. But if I get rid of the cube part, then none of that's there. And all I have is negative sine of blah 3 times that dx. And that works for me, right? I can go negative 3, negative 1/3. So all of that would be my du, and I would have negative 1/3, right? Du, and a 1 over what? U cubed. And I don't use natural logs for these, do I?
No.
Only if it was 1 over u do I use a natural log. So I would have to treat that like a u to the negative 3. So negative 1/3, blah to the negative 2,
Just put it over 2.
1 over
Let it erase the-
negative 2, and then bring your u in, cosine 3x minus 4. So you'd end up with 1/6 in parentheses cosine 3x minus 4 quantity negative 2 plus c. Now what is that? Cosine to the negative 2 is a what? Hold on, negative 2. Negative 2, not negative 1/2. All right, 1/2.
It's 1 over.
What is, it means 1 over, right?
C correct.
So that's the same thing as, you have this 1/6. That is a cosine squared on the bottom, isn't it?
Correct.
And what's a cosine squared on the bottom?
C squared.
So your answer on a key would probably be this. So if it was multiple choice, you're probably going to have this as an answer, and you're like, man, that's a lot to do to get there. Well, that's because, and again, there's nothing wrong with this. And if it wasn't multiple choice, you're fine to stop here. That's fine with me. But if it's multiple choice, it's not going to look that way. Are y'all seeing that? But what could I have done straight up from here?
Oh, you could change cosine to secant.
You could have changed that to secant squared on the top, right? Or just said, hey, if u is tangent, then du is, what's the derivative of tangent blah? Secant squared blah times 3. And isn't that secant squared blah? So all you would need to do is have the, 3dx. Are y'all seeing this? And if you want to do, and go ahead and move that up before you start, then maybe that would look better to you, and then you could just go, oh yeah, times 3, 1/3, there is my du, there is my u, so I get 1/3 integral tangent u du. And how do I integrate that? The integral of tangent.
See, I forgot.
That's one of those ones.
One times
Negative ln times cosine.
It's bothering me why. Okay, so if you don't remember that, which I gotta be totally honest with you, I forget it all the time.
Same.
Yeah.
So, and I really do. I mean, I've
Oh,
done this
isn't
for
it
like
negative
10 years.
cosine?
Do what?
Never mind.
Say
There
it?
was an absolute value there.
Wasn't it like
Yeah, there is an
negative?
absolute.
Yeah,
Negative
but guys,
cosine.
isn't tan u the same as sine u over cosine u?
Yeah.
So couldn't you do a w substitution here? And say if w is cosine, then dw is what? Negative sine u du? So w dw. So negative 1/3.
See, that seems like a big one for us.
Yeah, I did actually.
Are we gonna have one like that on the
Look,
first
look,
meeting?
that says like the one.
We did.
It's an ugly rule.
Yeah. But you gotta know that rule. If you know the rule, you don't have to do this substitution, right? You just don't see it a ton. So I would know the rule. So right here you get negative 1/3 natural log of w. And w is cosine u. And u is. This doesn't feel right. Doesn't feel very much the same. I feel like I made an error here.
Yeah.
Do you think you made it in which one though?
I don't know.
Which is for.
If I just made this up.
I said you give up.
If tangent is u, so the derivative is secant squared. Tangent
Oh, wait.
u.
Where'd
du.
where did the times 3 come from?
Say it again?
Where did the times 3 come from? On the du up there.
Derivative of that secant squared block d block.
Oh, yeah, inside, yep. Okay. But I don't know.
Here.
Can't put it in.
U is cosine. Du is. I don't know. I feel the same. Oh, wait. Why is this one cubed?
Now one squared.
Oh, of course they're different. We just did different problems.
Well,
Wait, what?
I thought it was
No,
always
it's cube because we moved down
Tangent.
oh yeah.
Oh, that's right.
well, you could plug in 1 for x,
It might
plug in
just-
1 when you calculate.
Yeah, why don't you just, why don't you just put it in the computer?
Well, you'll never know because of the C.
Right.
Because the C could be anything.
It's super funny.
Let me ask you this, guys. What if you do a problem, right, and it's multiple choice, and you work it, and you get this. And then you look for that answer and it's not there. But instead, you see this. Could it be true that it's that? Because what is tangent squared equal to? I mean, you know that this is a true statement, right? Pythagorean identities?
Plus 1 plus.
So if I replace that with secant squared x minus 1, what does this give me?
C.
That sometimes happens when you are like I know, it doesn't happen a lot, but every now and then, it usually happens when you are like extra creative and don't need to be. Like when you use some unusual process to get there and not maybe what AP is expecting you to do, you run into a situation like that and you're like, what the heck? It happens. Now the upside is, again, you guys will know how to do everything. I will equip you to make a 90, and you need a 69 to make a 5. And I say you'll learn everything, but like sometimes, realistically, I mean, I still miss on a 108-point test if I'm really on my game 4 or 5 points, you know? But I've had, I mean, usually I know how to do them. Every now and then I don't. Sometimes I go, what the heck? And then I see the key somewhere and I go, oh. But most of the time it's careless errors. That's going to happen. But guys, I've had kids make 93s out of 108. Mary Claire Alfano. Last year was not the normal test, but she was a little blonde hair cheerleader a couple years ago when y'all were sophomores. And she made a 93 out of 108. That's the highest score I've ever had. And it was even more impressive when you consider that a 5 was a 66 on that test that she took. Which was a really hard, no, she was a monster.
And you have some on like the practice AP test.
And you caught them with your video.
Yeah.
Oh, yeah.
Let's hear the story.
I told you he emailed me. He emailed me in his 4th year of college, and he says, I want you to know that when you caught me cheating and busted me,
It was a wake-up call.
he said, he goes, yeah, it was a huge wake-up call for me that what am I doing? Because he was a really bright kid, and he did great accents. Like he would like,
What kind of accents would you do?
all kinds.
All of them.
Yeah. But anyway, no, like he could probably do any nationality really accurately. But anyway, point is, he ended up being, what do they call them at Alabama? Like the capstone men or something. He ended up being one of those. And then they have this honor society there. It's like top 25 people on campus. He got that. He just wanted to know. It was a huge wake-up call because he had cheated in here. He had cheated on a not AP USS, AP Gov test, on an AP Chem test. And he'd been busted 3 times in 9 weeks. Yeah. He was terrible. But it turned, he said it gave him a huge wake-up call and turned around. And then ironically, he passed the AP test anyway. He didn't even need to cheat. But yeah, you guys will be prepared well. It's pretty tough because there's multiple tests out and they got you really spaced apart.
Gotta be 6'8" this year.
Let's see.
Who knows what will happen this year? Who knows?
So would there be like that kind of thing we would see on the test? Or that like a bonus or not at all?
This?
Yeah.
No, I would think that's a very fair problem.
Okay.
The cosine square on the bottom would make it a little trickier. But if you know your rule, you don't have to do this double U substitution. You know, if you just know the integral tangent rule.
Are we supposed to do that?
Yeah, it's on your sheet.
I'm just gonna make
There's an integral of tangent, integral of cotangent. But you can always do them by changing the sines and cosines and doing an U substitution. But it's less memorization for me, and I don't like memorizing when I don't have to. So if I can prove it, that's kind of where I might go to. But it did make it harder on me. Probably be easier just to memorize. I'd make you the you said 35?
Yeah.
Where's 30? Oh, right there. So I would pick that. I always go inside that power. So if I let u be the sine, then du is the cosine d theta. So I get integral of u cubed du. Go from there.
Okay. That makes sense.
Hey, y'all see 37?
Yeah.
For those of you that don't remember my rule, do you remember when I say when you take the derivative, like if you take a derivative of root x and you're changing it to the 1/2 power, you're not gonna see this easily, but what was my trick for that? Double it on the bottom, derivative on the top. That makes it easier, right? U, and then 1 over double it on the bottom.
Oh, that one is kind of tricky.
So 1 over 2 root x dx.
Yeah.
So 2 integral e to the u du. And then you're on your way.
Wait. Whoa.
Right?
Yeah.
Hey guys, if you do all these problems and just keep doing them and learning from them, your test is not going to be overly difficult. If you don't, you're going to have surprises on your test like we just saw today. And why do that to yourself? Just takes a little bit of work. I've got good keys out there. And if you still need help, come see me. Join the Akron Club.
Yes, sir.
I want to do the
When you pull up it.
Can I be secretary?
It takes him maybe 1 minute to walk in here, ask a question, walk out. I'm just saying. All right. Good chat.
Pound it.